Cool. Can you guys see this? A new in my ear?
Yes.
Cool. So I'm going to show you how the new setup, and I'm also going to show you a little bit about how this thing works, and then I'm going to show you where we're really stuck on optimizing it, and that's kind of the task that we want to focus on. So this is going to be an interesting task. It's probably going to require a lot of just like going into the kind of deep into the code and looking into the GitHub stuff and really getting to know how the core engine works. So in this case, we're using a framework called Reat.js, and I will pull it up. So there is an algorithm for determining like creating a rule-based expert system of flow, which ends up looking a lot like a node graph. And that algorithm is called the Reat algorithm, and it's a rule engine kind of framework essentially. That ends up looking like a bunch of nodes that then kind of flow out. And somebody created Reat.js, which kind of encapsulates that Reat algorithm and lets us make node editors in JavaScript. And in addition to Reat.js, which is the core library, there are also, you can see this is where the library is. There are also a lot of different plugins for it. You know, doc, area, connection, all these different plugins. And there's one plugin in particular that we use, which is very powerful and also like adds quite a bit of complexity to everything, which is called the task plugin. And so instead of it just being a graph on your screen, this task plugin lets you do really complex things, like run workers on the server who can respond with data, so that we can do these really interesting graphs. Let's see. That being said, we're using that inside of Thoth, and it powers the graph, and it's kind of the core engine for running our graphs and processing data and everything through. First, I'm just going to show you setup, and I'm going to start Thoth. So I'm going to delete that ugly console log. Let me collapse these. So Thoth is a mono repo, which means that it has several different Node.js projects inside of this single project. The main one is we have client, which is obviously the front end, core, which is all the stuff that's referenced by client and server, and this is also an npm package that you can install, and server. And then server itself actually is multiple different microservices, each which runs on its own. And you have the core server for handling cross-origin resources, entity server for handling like agents that spin up and actually connect to Discord or Twitter. You have the regular server here, which just starts up like your API server. We should probably rename that to API server. That'd be good. And you have a speech server, which handles like voice processing. And we also have the search server for handling search. And each of these services can spin up separately so that they can be put in containers and scale. But we're really interested, for our purposes, in this entity server, which we'll be looking at in a second. So to set up the project, we've changed it a little bit, even in the last few days. The first thing we have to do is we have to create a .env.local. So in the project now, we have a .env here, .env, and this is going to be committed to GitHub. So do not put secrets in here. This is not for secrets. This is for our default environment variables that we ship with. And then you override those by copying and pasting the file, renaming it to .env.local, and in .env.local, we can put our overriding secrets here. So I don't think I have any that are too harmful in this one, so I can show you. You can, I obviously don't want to like screen record my secrets, but I do have other secrets somewhere else. You can see the only thing I'm overriding is this React app use latitude. And this is really important if you're getting redirected when you start up the thing. It's because it's set up to redirect for our partner's like login system, and this disables it. Then in our server, we're going to do the exact same thing. We have a .env here. This gets committed, and we're going to override these values, especially like the API key values, with our own .env.local right here. Okay, and so once we have those set up, we're going to start up everything by running npm run dev. Oops. And we need to make sure that we are using node 16 or higher. And then we should see it just start up. Look at that. Everything is starting up, all good. Now, I believe that I was developing with the entity engine separately, and I should probably, one, we're using yarn, so we don't want that. Two, if we actually go in and say, well, when I run npm run dev, what's that doing? Well, first it goes into the root package JSON of the mono repo, and it calls dev here, npm run dev. And you can see that inside of there, it's calling cd server and docker compose up. Docker compose, well, we have a docker compose file which runs the database, which is a what is it for this? It's a Postgres database. So this starts up the database. If you don't have Docker, you could, I guess, hide this and start it up yourself, but it would be much harder. Also, then it calls yarn run dev server, which is gonna call. You can see right here, this one. It's gonna have learna execute yarn run dev within the scope of Thoth server. And so the scope of Thoth server would be this server package up here. And then outside of calling server, it also starts core and client, blah, blah, blah. But that doesn't really matter for what we're thinking about today. So it calls dev server, which is in this package JSON right here in the server package. And dev on the server, you can see calls server.ts, and then it starts running speech and running search, and it should.
Your voice is breaking. Is someone also experiencing the same?
I don't know. Is my voice breaking up?
Mayur?
Well,
no, it's fine for me.
Cool. Well,
Okay.
either way,
It's
Okay.
I'm unable to see video.
Oh. If you click on my name, it should say you can watch stream.
No, you can continue testing. I think Shaw, we do not need her in this, right?
Right, and I'm
Because
recording
this
this.
is technical.
I'm also recording this as a video, so I think I can hand this to you guys afterwards.
Okay, yeah. No, you can continue with the...
So that was the setup portion. When I go into this dev here, let's see. Sorry. I want to just add one more thing. I'm just gonna add, because I had removed this while I was developing, yarn run entity server, and you can see entity server calls source entity server. So we're starting up speech, search, and entity server in addition to the like regular dev server. And these are all all adjacent services that are, since we don't have threading in Node, we've split them up into separate services. So cool. That starts up. You can see that everything starts up with npm run dev in the root. I'm just going to restart it to make sure that it caught that command that I just saved. Now everything is running. That's great. So with everything running, let's see. I'm going to go to my Digital Beings test server. In a second. You can see everything is starting up. Starting agent, creating world, blah, blah, blah. And so what's actually happening is two things. One thing that's happening is that it's starting a front end, a server, a database, and everything else, but it's starting a front end that I can access from here. I won't be able to access it until Webpack compiles. Looks like you can see it's doing it. And there it goes. And so just be patient. Let's try that again. And I think what happened is that I changed so much stuff that the RxDB store is invalid. So if you get stuck in this please wait, and you can see RxDB error, another instance, different schema, blah, blah, blah. Okay, great. Well, then I'm going to make a new window. Nope, sorry. New private window. And that should fix it. Okay, this is what it's supposed to look like. Now I have a whole bunch of different spells I've made. I'm going to go to example spell. And you can see I have a spell right here. Awesome. And it does some different things. You can see I've got the playtest ready. And I've got a destructure for handling agents. And I've got an echo, which just, responds to the echo. And then an output and trigger out. And I'm going to say hello. And there's a bug in the playtest window where you have to send it twice in order to process the graph. And you can see I said hello, and it responded with hello because it is an echo. Great. In here, I have an entity manager. And the entity manager says, okay, I have this cool graph. And I could call this at a REST endpoint, no problem. We already have that set up in here. But I want an entity that can go on Discord, or can go on Twitter, or one of these real-time places that requires me to create a class and hold that class in memory and continue updating it. It's to make a Discord thing with Discord.js or a Twitter, I have to create a client. I actually create a new class of a client object, and then I hold it there, and it runs updates and all that stuff. And so that thing, this client, we call an entity, and I'll show you. Well, now that I've got everything running, I can go over here and I can say, "Hey Philip, what's up?" And hopefully, although one can never be too sure, you can see that it did receive it. Hey, what's up? Hopefully it is going to respond. If not, I'll have to figure out why. Yeah, there we go. Took a while to respond. And actually, that's the heart of the problem, is that what we're going to try and solve over the next couple of days is how long it takes to respond. See? Hey Philip, what's up? And he said, oh, what's up? I'm a bot that runs in the blockchain, and I like to talk about Kyrgyzstan videos, philosophy, and how the world will end. Okay, that's pretty cool. And you can see this Philip bot is actually running locally on my computer right now. And so how does that work? Well, I have another spell called default. And this is Philip right here. You can see there's a whole bunch of nodes. And so this graph is running in the background. And every time I send a message to Discord, it runs this graph. Great. So I'm very glad to hear that. Great. Thanks, Philip. He's a pretty smart bot because he's got a lot of functionality in here. And this is all going great. But he's very slow to respond. And so we're working on voice input, but if we add that on top, it's going to be like, it's going to take 10 seconds for him to respond to everything you say. It's going to be a very slow, painful conversation. So we want to solve that problem. So let's get into that. This is an entity, before I do, we have this entity manager here, and you can see I set the Discord API key, I set his bot engine name, can give him some responses, I set the actual spell that he calls right here, and I can also add him to XR Engine, which is our 3D world, and as well as Twitter if I want to. You can see I can add Twitter data. Great. And so I have him on Discord. He lives there. Now he is, I've been talking to him. But he's very slow. And so I go to my server. I have a folder in my server folder called entities. And this is the code to actually manage entities like Philip. So first we'll start the entity server. When I initialize the entity server, it's going to create a new database instance. Then it's going to create a new world and a new room manager. And we're not too worried about the room manager. It mostly manages. I don't even really know what we're doing with the room manager anymore because we moved a lot of this to the database. So we should probably think about that. To my knowledge, I think what we're doing with it is using it as a way to remember who we've been talking to and to respond to them properly. But anyway, what we really care about is this world. And so in entity component systems and similar stuff, the world is kind of like the place where all of the entities exist within. And so when we create a new world, that will set up a basic loop and allow us to create entities basically by listening to the loop and updating. So when we get a new entity or have to edit an entity, we're going to create a new entity through this. Let's see. Say, oh, we got a new entity. If we say update entity, oh, new entity, we'll create a new entity. And then when it creates the new entity, it looks at the data for the entity and decides, should I start Discord? Should I start XR Engine? Should I start Twitter? And so this entity class is where we instantiate the entity. And so the entity is on Discord, gets a message, and wants to handle that message. So this is the most important part of actually, if we've been drifting off into space, what I'm going to say for the next 5 minutes is probably the most important part to actually doing this task. The task is to optimize our current handler for messages coming in so that it runs much, much faster. And the reason that it's running slow is because we're reprocessing the entire graph every time we get a message. It would be like rebuilding your entire code base for a HTTP endpoint every time. It just doesn't make sense.
Yeah.
And, so when we start Discord, we call start Discord. And inside of that, we have this function called create spell handler. And really, we don't actually need to worry about any of the code around all the stuff we just talked about, except for this function right here. This is where we're setting everything up. This is where our slowdown happens. So we create the spell handler, and this is actually going to return another function. But we're going to set that function up with a bunch of stuff in the closure. So we create a new engine and this engine is like the read.js graph engine. We're going to get the spell that we were working on, which is spell and graph mean the same thing in here, but this is the spell. We're going to get that one. We're going to, and this is just some validation. We're going to build a new interface for basically set up the inputs and outputs and everything as needed. I think. I don't know. I don't really mess with this. We're going to create a new module And so this is really important because this is where all of the input and output data gets stored. We're going to set the modules on the module manager if there are any modules within our within this module. Like this maps out the modules to the engine. And then we're going to, I know this doesn't mean anything if you don't know the code, but basically this is all like set up the context, get the first trigger that we're actually going to call on that graph, you can get more of the trigger, and then right here, we're going to process the graph. And so we process the graph, we get the outputs set up, and we're good to go. We don't actually return anything here. What we're doing is we're going to process the graph, prepare everything for input, and then return another function which they can call, which handles the actual chat. So this is all working. It does what it's supposed to do. When they call, when they send us a message, it goes through spell handler. And we get the message and who's talking and the agent and everything. And in spell handler, let's see if we can collapse it. You can see that we're like creating this function and returning it, right? And we're returning it to the Discord client. Like, hey, call. This is your callback whenever you want to deal with the message you got. So inside of here, well, I mean, we did everything we wanted to do and set it up. And so we should be able to just go and say, okay, cool, we set it all up. Now go through and we can delete this. Get the inputs and run the actual module. This await component run. This like starts off the whole chain. And it works. But it only works the first time. And I'll show you what I mean. Let's see. Hey, Philip. Oh, he's not awake yet. It takes a little while for him to connect. You can tell when he's connected because, one, he's online, but two, it should say, like, shards complete. There you go. Cool. Shards complete. Sending a heartbeat. Received all its guilds. And now we can do that again. You can see he got the input. He's handling it. And you can actually see what the outputs and blah 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 are. Pardon me, I can't respond to that name. How about now? Ah, now this is the problem. Every time I message him, well, he doesn't actually process again. He doesn't figure out what he's going to say. He just responds with the last thing he said. Because the node graph has not been reset. It has not been cleared. And the way that it's set up is it says, oh, I already have that data for those nodes. I already completed those, so why would I run them again? And we don't really know where, but somewhere in here, because of the way the task node is working, we cannot, we have to reprocess the graph in order to chat with him more. And the reprocess takes like 10 seconds. So every time we want to chat with him, it's really slow. And so if we didn't have to reprocess the graph every time, which we shouldn't, there's absolutely no reason we should, we would, it would be very, very fast. And then we could set up WebSockets and streams and all of these different things for like real-time communication because we wouldn't have this massive delay of having to load it every time. So the task is really specifically when we call create spell handler and we set all this stuff up and we return this async function spell handler. We'll return this this is the callback for Discord XR engine. It's set to enable chat, right? Just a little comment. When we call this, we want to make sure that it reruns the workers on and reruns the tasks that are associated with this graph. So I've noticed.
Sure,
Yes.
yeah, sure. One thing right now, we have to work on optimizations, or we have to work on that demo thing. Like,
Well, this is the most important killer part of the demo, because every time I say hello to the agent, it takes 5 to 10 seconds to respond. Right? So it's really, really slow. And that's because of one line of code that slows everything down, which I removed, actually. Let me put it back. It would be right. Doesn't matter where it is. Here. Await engine process. This resets everything. We need to replace, except the calling this function. Cool. So and we'll say test case chatting with agent on Discord doesn't get the same response over and over. Cool. So this is the thing we have to fix. I know this is complicated. It's very complicated. And I think it's going to require some time to really understand what's going on. But inside of engine process, well, it's resetting everything. And we don't have to do that, though, to reset everything. We just have to reset the tasks and the outputs of the tasks or something. I'm not sure what. Things I tried like clearing all the task outputs, etc. And it was confusing. So the order of operations to fix this, the first one is to look up Read.js task plugin. Which I will put right here. 2, we need to look up the functionality of run once. No, need update, need reset. Look up functionality of need reset. If all tasks are reset, this will work, but it doesn't because some nodes need to not be reset. Or they all need to be reset at the same time. Right. So we could add all resettable nodes to global list and then reset them from there after all tasks run. And so that's I'm sorry that I'm kind of like speaking this out as I write it, but essentially let's see, I should probably add one more. Look at task.closed. This important to tasks being done, and then we'll say look at task.worker. since this is where the logic actually happens. And then look at node.builder. And then which creates instances of nodes. And then lastly, look at anything named task or task. Or output. Cool. I'm sorry this is very convoluted, but the entire task revolves around basically, can we get this to not be there? Just comment this out, and when we talk to the bot through Discord or through anything that uses this spell handler here, can it be fast? This engine process here also gets run in run spell, and the way that this is set up, it kind of has to right now, because it's not like not an agent. It needs to be able to run any spell, but it does do the same thing, and it's very slow because of this line of code right here. So we might like this code, this run spell code is actually the same as our spell handler, but it's handled differently. And you can see it's kind of the same order, but we have to call this here because we don't have the ability to like pre-process for the agent. Whereas in our spell handler here, we actually call this, before we create the spell handler, right? You see, we process it before we return our handler, so we shouldn't have to call it here. And if we can get rid of this, then we've done the task. I'm sorry that was very complicated, and you'll probably have to go back and look at all of this, but hopefully that's a little helpful.
So, till when we need it, sure.
Sorry?
Till when we need this task to be completed?
As soon as possible. If it could be part of the demo, I mean, if I sat here and worked on it, I think it would probably take like another 10 or 20 hours. But I've also spent a lot of time already looking into it. I just think that it's like kind of a complicated problem.
And who should work on this specific task, this optimization
I think
task?
Mayer, if you're still around, if you could handle it, that would be ideal. Also, we do have help. We have Parzival, who wrote the like most of the code in here and can help with like how this stuff works. So we'll make a group chat with him so that you can like ask him. But he's only going to be awake during my hours. That's the only problem.
So he might be already slept.
Yeah, he already is today for sure. So mostly today I think you're going to be doing research and like looking this and trying to get it to work. Definitely.
So if Mayur has any questions, can he ask from Alex or no?
Yes. And we should probably send this exact same video to Alex so that he understands this stuff.
I will.
'Cause he hasn't gotten deep into this either yet. But yeah, totally.
Okay. So please send us the video. I will do the needfuls. You can send me. I will distribute it to the Alex and we will have a discussion on this.
Great. I'll throw it on YouTube.
Okay.